Hi everyone. Today is the first section of our Math 2 book, so we're going to go back to Module 1 and start over in the new book. And the first section out of our new book is on perpendicular bisectors. Now, we know what each of those two words mean separately. Perpendicular lines means two lines that meet to form a right angle, or a 90-degree angle. And to bisect something means to cut it exactly in half. So if you put those two words together, if I tell you something is a perpendicular bisector, I'm just telling you both of those things. So here's an example. In this picture right here, we have line segment AB. That's the one that's going horizontally, the one that's going sideways. Then you have line CD going down the middle. Now I said in the picture, line CD is a perpendicular bisector of line segment AB. That's because the line cuts AB exactly in half, and you can tell because AD is marked congruent to DB, and it has the little box in it for a right angle. So that's what perpendicular bisector means. It's two words you guys already know. We're just putting them together. Now, we're going to learn the perpendicular bisector theorem to go with it. So I put that same picture on. I'm going to use that same picture we had from the last slide. Here's what the perpendicular bisector theorem says. It says a point on a perpendicular bisector, like point C up there, is equidistant from the endpoints. Now, equidistant, just like what it sounds like, equal distance. So C is the same distance from A as it is from B. Or another way to think of it, in that picture, the two red line segments, AC and CB, are congruent. So if you have a perpendicular bisector, like our original picture, we had AB being bisected by CD. If I pick any point on that line CD anywhere and connect it to A and connect it to B, then what happens is the two lines that I make by connecting it are always congruent. So let's solve for x. Let's take this picture right here. It's a triangle. It's triangle HKN. Got a line going down the middle, KB. And what I notice is that that line, KB, is a perpendicular bisector. Now, I didn't write in the directions like I did on the last slide. I didn't say in words, KB is a perpendicular bisector, but I know it's a bisector because I have my two congruent markers here. Line segment HB is marked congruent to BN, and I know it's perpendicular because it has the right angle marker. So if it's perpendicular, and it's bisecting or cutting the line segment exactly in half, then it's a perpendicular bisector. Now, once you notice it's a perpendicular bisector, our theorem says, even though it wasn't marked in the picture, this side here is also congruent to this side here. And if those two sides are congruent, then these two expressions are equal, and that's what we're going to use to solve the equation, or to solve for x. We're going to set those two things equal to each other, 3x equals x plus 10, and then we're going to solve that equation for x. So the first thing I would do, I want to get rid of that x on the right. I'm going to subtract 1x from each side, cancel that one out. 3x minus 1x, or just x, is 2x. We have just a 10 left on the other side, and then we'll divide by 2. And our final answer is x equals 5. So remember, when you're doing a geometry question like this one, not a proof, but an actual solve for x question, it's always two problems. The first part of the problem is to set up an equation correctly. You got to know which things are equal, maybe which things add up to 90 degrees or add up to 180 degrees, or maybe one thing is half as long as the other. You got to know the relationship from the picture to set up the equation. And then part two is actually solve. Okay, I'm going to give you guys another vocab word. The word is circumcenter, and it's very closely related to perpendicular bisectors. So basically, if you take a triangle, and for each one of its three sides, you draw in the perpendicular bisector, the point where those three lines meet is called the circumcenter. So here's a picture. The red arrow is pointing right to it. So I drew a triangle, and you can see that each of those blue lines is a perpendicular bisector. And again, for the same reason we just talked about, like the one on the bottom, I know it's a perpendicular bisector because these are congruent, so it cut them in half, and it has the little box on it for a right angle. And then I could do that for each one of them. The one on the right side, I know it's a bisector because these are congruent, and I know it's perpendicular. And then finally, I know that this one's a bisector because those are congruent and it's perpendicular. So the three blue lines in this picture are all perpendicular bisectors, and that one point where they meet, that's called the circumcenter. So let's learn one last theorem for today. The circumcenter of any triangle is, and there's that word again, equidistant or equal distance from the three vertices of a triangle. So here's a different picture. Now notice each one of these is a perpendicular bisector. So let's say, actually the one on the bottom isn't marked. Let's fix this one up. Let's say, just so we know, that this is also a perpendicular bisector. So let's say this picture is the circumcenter. So like this is congruent to this, these are congruent to this, or this is congruent to this, and then these two pieces over here are congruent, and each one is marked perpendicular. So that point O in the middle is the circumcenter. Now what our theorem is saying is that all three of those dotted lines from O to A, O to C, and O to B, those are also going to be congruent. And if you look at it, each corner of the triangle kind of represents, or not each corner, I guess each perpendicular bisector represents the theorem that we just talked about. So if I start, let's start with this one over here on the right. If I start with that perpendicular bisector there, by our first theorem from today, this line segment here is congruent to this line segment here, because O is a point on the perpendicular bisector and it's connected to the ends. Then I say, okay, well, let's look at this one. And I say, well, on this perpendicular bisector, it says that this line segment here is congruent to this one here. So basically, all the dotted blue ones ended up being congruent to each other. And let's finish up with one example for today. All right, so in this picture, we have triangle ABC. And I told you in the directions that D is the circumcenter of ABC. So basically, each of those three line segments that are cutting, each side in half, it's GD, FD, and ED. Each of those three is a perpendicular bisector. And then I give you some more information. Let's fill that in. So the first thing I told you is that AC, all the way across the bottom, is 9. I told you that DE is 2, that's right here. And I told you that DF is 1.5 right here. And I want you to find BF, which is up here on the kind of the top right. I'm going to call that X, and we'll turn this into a solve for X question. Now, the one thing I can do, if I know that AC all the way across the bottom is 9, and I know that DE is a perpendicular bisector, which cuts that 9 exactly in half, then I can do 9 divided by 2, and that'll tell me that each of these sides here, or each of these line segments here, is 4.5. Now, when I go to make my plan, I want to solve for X, and what I see in this picture is actually a whole bunch of right triangles. And when I see a right triangle, I think of Pythagorean theorem like we did on Monday. Now, in order to use the Pythagorean theorem to solve for X, I need to know what this line segment BD is right here. And that wasn't given in the question. Now, what I know from my theorem about circumcenter is that that line segment BD is congruent to this one and this one. So if I can find either of those two, then I can use that number for BD. Now I look at either of those triangles in the bottom actually, the bottom left or the bottom right. Now I can use Pythagorean theorem to find the missing side and then use that for BD. So this is going to be a two-step problem. Step 1 is I want to find out this one right here. Let's do this one right here. I'm going to put a question mark right there. because that question mark there is going to be the same as the black question mark above. Now to solve that question, because it's a right triangle, I can use Pythagorean theorem. A squared plus b squared equals c squared. And if I'm looking at that right triangle in the bottom, the question mark is the hypotenuse because it's opposite the right angle. So what I'm going to do, I'm just going to leave that. I'm going to call it C. We don't know what that is. Now the A and the B are the legs of that right triangle, and that's going to be the 2 and the 4.5 here. Those are the legs. So I'm going to do 2 squared plus 4.5 squared. And if you do that on a calculator, let me do the calculator work, I'll come right back. That comes out to 24.25. That was 2 squared plus 4.5 squared on a calculator. And then remember what we talked about on Monday. When you're doing Pythagorean theorem, you always get to this point where the thing you're trying to solve for, you have it, but it's squared. I want to solve for c, and I have c squared. When you get to that point, what you do is you take the square root of both sides of an equation. Taking the square root of something that's been squared cancels the exponent and just leaves that variable. So I found c. It's the square root of 24.25. I'll just do the calculator work again and come right back. Okay, I'm going to round off and call it 4.92. Now that's not the answer to the question. What that is the length of these two question marks right here. And the whole reason I did that, the reason I wanted to know what that is now I can actually solve for x and answer the question. So let's put that number in. Let's take that question mark out, since we know how long that is now. And let's call this 4.92. And now what I'm going to do is I'm going to do Pythagorean theorem again, but I'm going to do it on this triangle up here with the x and the 1.5 and the 4.92. So let's do Pythagorean theorem again. A squared plus b squared equals c squared. Now remember, the c has to be the hypotenuse, and the hypotenuse of this triangle is the 4.92. That's the side that's opposite the right angle. Now in this case, the legs are the x and the 1.5. In either order, I'll do x squared plus 1.5 squared. And I'm going to pause for the calculator work again. I'll be right back. All right, so on the calculator, we had 1.5 squared is 2.25, and 4.92 squared came out to about 24.2. 24.20 something, I rounded off. Now, what we need is, we're not ready to take square roots yet. Don't do the square root part yet. We got to isolate that x squared first. So my next step is to subtract 2.25 from each side. And x squared equals, you can use a calculator again, it comes out to about 21.95. Now you take the square root. So once you get, remember we're trying to solve for x, once you get to where it says x squared equals something, that's when you do this. And we'll use the calculator again. I actually already did it last time I paused. It comes out to about 4.68. So there's your final answer. And that was kind of a hard question. There was a lot of work there. You had to do Pythagorean theorem twice. So on the first part of this question, I did the Pythagorean theorem on this triangle down here to find that question mark. Once I knew what that question mark was, I used my theorem about circumcenter to show that it's the same as that one. That's where the 4.92 came from. Then, the second step, I said, now I have to do Pythagorean theorem on a completely different triangle, the one I circled in purple. So the first half of the question, I did Pythagorean theorem on that triangle I circled in red. The second half of the question, I did the one I circled in purple. But we put it all together. We did answer the question. The question asked you to find the length of BF, and the answer was 4.68.